Welcome to this rerun of the exam in Business Economics from December 2014. Before we start, I should point out that you ought to have opened a graphical calculator, such as this, for example, and some useful Excel sheets. And at the exam, that would be a good idea to have these tools opened before you start. Otherwise, we will start with exercise 1.1. In this case, we are asked to determine the price that will yield the maximum admission income, that is, the maximum revenue. And in this case, we get a lot of information. For example, the number of guests at a price of 150 kroners and at a price of 175 kroners. We should not pay too much attention to that because we have to find the price that will yield the maximum admission income. And to determine that, we should find the marginal revenue function. And we can find that from this demand function given up here. So that's the method we use. We find the marginal revenue function, and we know that marginal revenue is equal to the demand function but with double slope. So in this case, marginal revenue will be equal to minus 0.00025x, I just write x instead of q, but you can do as you please, plus 250. Now that's the marginal revenue function. Next, we should know that when revenue is maximized, marginal revenue will be equal to 0. That is the point where we maximize revenue. And that is, we set MR, or marginal revenue, equal to 0. And in this case, we'll get minus 0.0025x plus 250 is equal to 0. And we can actually show this method by using the graphical calculator and at the same time solve for x. In this case, I'll just write minus 0.000125x plus 250. That's the demand function. Next, I'll write minus 0.0025x plus 250. That's the marginal revenue function. At this point, I can't see any of the curves in the diagram, so I have to change the settings up here. And the y-axis should start at 0 and end at 250, because that's the constant in our functions. The x-axis should start at 0, and I'm not quite sure where it should end, but I'll just continue increasing the range, and this looks about right. So as we can see, marginal revenue starts at 250. What that tells us is that at this point, revenue will increase by 250 if we lower the price to sell one extra unit. And we can see that it will increase revenue to lower the price and sell more units as long as the marginal revenue function is positive. As long as it is a positive number, revenue will increase if we lower the price in order to sell more units. However, at this point where we sell 1 million units, marginal revenue is equal to 0. And if we go beyond 1 million units, marginal revenue will be negative, meaning that if we lower the price further in order to sell more units, the revenue will actually decrease. And that is why at this point revenue is maximized at 1 million units. And if we solve for x in this function, you will also find that x is equal to 1 million units. So that's the first step. The next step, that is to insert x, which is equal to 1 million units, into the demand function. And the function will then be p equal to minus 0.000125, and instead of x we now write multiplied by 1 million, and next plus 250. And now we could solve that equation, but we can also read the answer graphically, because what we should do is we should find the value on the demand function for a quantity of 1 million units, and the equivalent price is 125, as we can read here from the graphical calculator. So a quantity of 1 million units corresponds to a price of 125 Danish kroners. So it will be at a price of 125 Danish kroners that revenue will be maximized, because that is corresponding to marginal revenue being equal to 0. So we write P equals 125 Danish kroners, and then we can write a short explanation. Hence, revenue will be maximized at a price of 125 Danish kroners, and we can just write in brackets when marginal revenue is equal to 0, that is when revenue does no longer increase when we lower the price. Instead, if we lower the price further, it will decrease. So this is the pinnacle, this is the maximum. So that's exercise 1.1.